Okay, so here I'm going to find the solid of base, an ellipse with major axis 9 and minor axis length 4. So the major axis is the longer one, and it could have been on the y-axis, but it doesn't specify, so I just chose it to be on the x-axis. If the major axis is 9, then half of that is going to be 9 halves. And similarly, if the minor axis, the shorter one, is 4, then half of that is going to be 2. So this is what my ellipse looks like, and this is the equation of an ellipse. So we've done something like this before, except now we want to find, basically we want to find squares. So that's one base of a square, and if I kind of project this out into 3D, a square is kind of going to be standing up in the middle like that. So, and what's the area of a square? Well, it's just one side literally squared. So all I really need to do is to find the length of this side and then square it and then take the integral over that. But here we can utilize the symmetry of the ellipse. So actually all I need to do is find out this quarter and then find out this length, multiply it by 2 and then squared. So again, I'm going to have this equation, and I'm going to do some algebra on it so that I can get y as a function of x. So let me do that real quick. Here we have y squared, 9 squared, 1 minus x squared over 4. And I'm going to multiply both sides by 9 halves. 9 halves squared, that is. Okay, so now I have y squared is equal to, let me put it as 81 over 4, 1 minus x squared over 4. And then I don't want y squared, I want just y on its own. So I'm going to carefully take the square root of both sides. And when I do that, I have to take the absolute value of y. And then now, 81 is a perfect square and so is 4, so I can take that out of it. So it's going to be 9 over 2. But the rest of this is still inside of the square root. So I still have x squared over 4. And since we're only looking at the top half, notice each of my y coordinates here are positive. So here y is very conveniently positive, so I don't need the absolute value anymore. I'm just going to say y is equal to 9 halves. And inside of this fraction, let me simplify this so that it becomes one whole fraction instead of a mixed number, or a whole number and a fraction. So that's going to be 4 minus x squared all over 4, which is nice because 4 is a perfect square, so I can take that out of the square root. So now I'm going to have 9/4 multiplied by 4 minus x squared. And that's the most that I can simplify that. So if we were just looking at this quarter, the equation of that line, or that curve, is y equals 9/4 4 minus x squared. So what do we need? We need this length right here, and this length is just the y coordinate. So I'm pretty much done. Let me draw a square. Half of that. So the length of this square is actually going to be 2 times the y coordinate, which is going to be 2 times 9/4 4 minus x squared. And then I want the area of this. Actually, what I really want is the volume, because I'm taking a chunk out of here. So I'll say that this is, we're splitting it up, partitioning it with respect to x, so delta x. So the volume of one little slice of a square is going to be twice this, and then it's going to have some thickness to it, right? And that thickness is going to be delta x, or dx in the integral. So I'm going to take this, and I'm going to square it, and then I'm going to multiply it by delta x. So now I just need to put it into my integral. What are my limits of integration? I'm taking this from 0 to 9 halves. Because again, we are utilizing the symmetry of the ellipse. Okay, So I'm really getting it from here to here. But we want the entire thing. So what I can do is just take the integral from here to here and multiply it by 2 because it's symmetric about the y-axis. So I'm going to say 2 times this integral from 0 to 9/2 of this whole thing. And this is pretty much all of these little volumes split up. So now let me simplify this a little bit. Here I have, if I reduce, I'm going to get 9 over 2, 4 minus x squared, and then all of this is still being squared, and now I have the dx out here. Okay, so if I square it, I'm going to get 81 over 4, and now the square of a square root will just be what's on the inside. So now I have 4x squared dx, and I can go ahead and take this out because this is a constant, and I'll get a little bit of reduction. This will be 2 on the bottom. I'll get 81 over 2 from 0 to 9/2 of 4 minus x squared dx. Now we're pretty much home free. I just need to integrate this, which should be pretty simple. Let's see, that's going to be 4x minus, using reverse power rule, x cubed over 3. And I want to take that from 0 to 9/2. At 0, these are both just going to go to 0, so I don't even need to calculate that. I just need to plug in 9/2 in there. So 4 times 9/2 minus, let me write it like this, 1/3 9/2 cubed. So what does that give me? Let me reduce it a little bit. I have 2 up here, so this is going to be 18 minus, and then here I have 9 times 9, okay, let me write it like this, it'll be a little bit easier. 9 is really 3 squared, so I'm going to write it as 3 squared, and then the whole thing's cubed over 3 times 2. Using my rules of exponents, anything with the same base and different exponents, I can just subtract the exponents. So that's going to be to the power of 6 minus 1, so it's going to be 3 to the 5th power over 2. So I'm running out of room and time, so I'm going to just let you simplify that, but we're pretty much done. Hopefully that was helpful. Let me know if it wasn't.